This is a recording for in-class 14 in case you are absent or need to go back to those notes. This is standard 4 where we are working on transformations of objects. And today's topic is rotations. So first and foremost, the most important thing to remember when we rotate is that we're always going counterclockwise. So if you look at a clock and you watch the second hand ticking around, we're going to move in the opposite direction of that hand, which means we're moving around kind of backwards. That's really important to remember because we're going to be turning our papers as we're doing rotations. And so if we turn the wrong direction, then your rotation won't end up showing up in the location it's supposed to. So our first goal is going to be to just deal with the rotation of a single point. You might be saying, well, there's 2 points on these graphs, but we are going to rotate around the origin, and so that means that point A isn't going to move. It's just going to be point B that moves. So if we're traveling 90 degrees and we're going counterclockwise, that's the same thing as taking our paper and spinning it backwards around the clock until it's a quarter turn. So it's going to end up looking kind of sideways on your table. What we're going to do is we're going to take a snapshot. So we're going to look at where B is at currently, and we're going to write down that ordered pair as if this was a regular XY graph. So it looks like from the origin, we're moving 2 to the left, so that X value is -2, and then we're moving 1, 2, 3, 4, 5 full boxes up, so the Y value would be 5. We flip back to where our original graph is at, and then we just graph what we just saw. So we're going to go 2 to the left, 1, 2, 3, 4, 5 up. That's going to give us our location for B prime. And then since they asked us to rotate the ray, we're going to connect that to A, which would also be A prime. And what should look like it's happening is a nice 90-degree angle in between our pre-image ray and our image. The other type of rotation we'll learn how to do is 180 degrees. Again, we're going counterclockwise. So this time when we turn our papers, we're not going to do a quarter turn. That's only 90. We're going to do one more quarter turn. That takes us to a full 180. So your paper is going to look upside down. This is a snapshot of where B prime is going to land. So again, we're just going to pretend like this is the origin, regular X and Y axis. So I'm traveling 1, 2, 3, 4, 5 boxes to the left. That means my X value is -5. And then I'm traveling 2 boxes down. So my Y value is -2. It's going to look upside down in your paper when you flip it back, but just be careful. -5 is your X. So 1, 2, 3, 4, 5 to the left. -2 for Y. So we're going to put that point right where it belongs. Label that B prime. Remember, A prime doesn't move because it is our center of rotation. And then we can connect our A prime to our B prime, and we get a nice 180-degree straight angle, just like we would expect with a 180-degree rotation. All right, last but not least, we go 270 degrees. Remember, we're going counterclockwise. So that's going to be 3 90-degree turns. So this 90 completely upside down is going to be 180. So then one more quarter turn is going to be 270 degrees. Take a look at where you've landed. Looks like we're going 1, 2 to the right. So B prime is going to have a positive X value. And then 1, 2, 3, 4, 5 down means Y is going to be negative. Go ahead and flip that back. And we're going to graph that B prime point at 2, -5. A prime stays where A is at, and we connect. You might say, wait a minute, that looks like a 90-degree angle, not a 270-degree angle. Well, you're right, that is a 90-degree angle, but this is clockwise. 270 describes the counterclockwise rotation. So going 90 degrees clockwise is exactly the same as going 270 degrees counterclockwise. So if you wanted to, for 270-degree rotations, instead of going 3/4 turns counterclockwise, you could just do 1/4 turn clockwise as a shortcut. But that's the only time you should be turning clockwise. Okay, that's an intro. Now we're going to get into specifics. So a rotation is a transformation that turns a preimage around a point which is another way of saying about a point, so either around a point or about a point of rotation. And then it's a given number of degrees. And the degrees that we will use are either 90, 180, or 270. You could also fill this blank in with the word clockwise, or not clockwise, counterclockwise, if you thought you were going to forget what was up above. So a transformation that turns a preimage counterclockwise about a point or a preimage around a point. All right, after that, it's just all about practicing with a triangle. So the tricky thing about a triangle, instead of what we did up above, is that there's going to be more than one point that rotates. So when we turn our paper and we get our snapshot of our answer, we're going to have to make a list of more than one image point so that when we flip it back, we can get all 3 vertices of the triangle graphed in the right spot. Here we go. First things first, we're going to pay attention to the number of degrees that we are rotating. So 180 degrees counterclockwise is going to mean that we're rotating our paper kind of like to the left, 90 degrees, and then 180 degrees. So it's going to look upside down. So if I'm at 0, 0, it looks like B is going to be to the left and down, while A and C are both to the right and down. So we're going to be really careful with our positive and negative signs on our ordered pairs. I'm going to get them all set up here, and then we're going to track them down. I'm going to fill in B first, because that's 1 to the left, so -1 for X, and then 1, 2, 3, 4, 5, 6 down, so -6 for Y. A is 1, 2, 3, 4, 5, 6 to the right, so positive for X, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 down, -9 for Y. And then last but not least, C is going to be 7 to the right, +7 for X, and then 1, 2, 3, 4, 5 down for -5 Y. All right, let's flip it back. Get our points graphed in those locations. It's kind of tricky to read them upside down, so just be careful. Your X value is 6, 1, 2, 3, 4, 5, 6, and your Y value is -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. A prime. B, -1, 1, 2, 3, 4, 5, -6. And then C prime, 7 for the X value, so we're headed to the right, and then down to -5 for the Y value. Go ahead and connect those together so you can see your image. Triangle A prime, B prime, C prime should be the same size as this one, but it looks like it's spun around. So it's kind of like upside down looking since we went 180 degrees. If we were to connect, and I would not recommend you do this on your notes, but if you were to connect a pre-image point to the origin, what we rotated around, and then out to the image point that matches it, do you see that perfect 180 degree rotation? That should happen if you connect A and A prime or if you connect B and B prime. All right, next up, 90 degrees this time. So again, counterclockwise, but 90 degrees is only a quarter of a turn. So we turn it a quarter of a turn, and then we try to figure out what our A prime, our B prime, and our C prime points are going to be by taking a look at this rotated view. B is 3 to the right, but not up or down at all. So that means my x is positive 3 and my y is 0. For A, I don't move left or right at all. I just move down. 1, 2, 3, 4, 5, 6, 7. So my x value is 0. No right or left, but my y value is negative 7. And then for C, we're going to move to the right 4. So that's our x value. And then down 1, 2, 3, 4, 5, 6, 7, 8. That's a little tricky to count in there, so be careful. 4, 8. So we've got our ordered pairs for where our image is going to land. We can flip it back and graph them where they belong. Be careful with those ordered pairs that have zeros. A prime is at 0, negative 7, so no right or left, just down 7. B prime doesn't have anything for y, so just 3 to the right, no up or down. And then last but not least, C prime, we're going to go 4 to the right, and then 8. Ooh, I forgot. Let's check this a second here. That y value should be negative. Sorry about that. Glad I caught that. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. And I knew that was the case because I was anticipating my shape, which used to be kind of horizontal, rotating around 90 degrees and becoming vertical. So it would not make any sense for my C value to be way up there. It's got to be down kind of nearby the A, just like the A and C are in the pre-image. So sometimes you can carefully check and catch mistakes that way if you're thinking about what you expect that triangle to look like when it's rotated. All right, we will do number 3 next. 270 degrees. So again, you can go counterclockwise 270, so 3/4 turns, or like we found out up above, that's the same thing as 90 degrees but clockwise. So you can do 1/4 turn clockwise, or you could do 3/4 turns counterclockwise. So we've got our A prime, B prime, and C prime. C is at that center of rotation, so it's not going to move at all. 0, 0. A prime looks like it's going to be 1, 2, 3, 4 to the right and down 1, so 4, negative 1. And then B prime looks like it's 1 to the right, 1, 2, 3, 4, 5, 6, 7, 8. So 1, negative 8. I'm not going to lose that negative sign this time. Back we go to the original graph. Get everything reoriented where it belongs. And then graph carefully. So 4, negative 1. 1, 2, 3, 4 to the right, down 1. That's going to be our A prime. B prime at 1, negative 8. And then C prime just stays right where C is. So if we connect these together, that triangle is rotating 90 degrees clockwise, which would be the same thing as that triangle starting out here and then rotating 90. Oops, sorry, you can't see, my arm's in the way. 180 and then 270 counterclockwise. Looks pretty good. 4 and 5 are not really any different, so for the video, I'm going to let you try those. You can access the filled in notes on Schoology if you were absent in the purple more detail folder to see if you did those correctly once you try them. but I am going to look at number 6 with you quickly because this is a working backwards level 4 question. The goal is to describe what's happened that's mapped the pre-image to the image. So first remember the pre-image is the one without the primes. So this triangle right here is where we start, and this is where we land. So the goal is to get a triangle down here in the 4th quadrant that's kind of pointing to the right. Let's test out a 90-degree rotation. Nope, it's in the 2nd quadrant pointing to the left. So let's go for 180. Nope, it's in the 3rd quadrant pointing down. So hopefully, fingers crossed, 270. Is that going to take care of it? It's in that 4th quadrant. It's pointing to the right. Everything checks out. So this looks like it's a rotation. Of 270 degrees, and then we always say about the origin, which might seem a little bit silly because we don't do rotations around other points, but other math people do. So it's good for us to be specific about the fact that we're rotating around that origin point when we're rotating. All right, last bit of information. If you reflect through all of the rotations we've done, a rotation does or does not change the size of the pre-image. So are the triangles getting bigger or smaller, or are they staying the same size? They are staying the same size. So rotations do not change the size. This is a little trickier. A rotation does or does not change the shape of the pre-image. The answer to that one is also does not. But sometimes when those triangles rotate, they end up looking a little bit different just because instead of being like up and down, they're kind of laying left to right, but it's still the same shape. If we measured the sides, we measured the angles, everything would still match. A rotation does or does not change the location of the pre-image. It absolutely changes the location. It's going to be in a different location depending on how many degrees it's rotated. All right, make sure you fill in those last 2 examples and double check your answers in the more detail folder with the in class 14 completed notes, and then homework 14 would be your assignment.